Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome to episode 68 of the Reliability Matters podcast. My name is Mike Konrad. I'd like to welcome you to this podcast. In fact, I'd like to say hello from Mexico. Hola desde Mexico. I am on vacation, and that might explain some of the birds chirping in the background and some of the other interesting noises you might hear. There's your explanation. This episode, number 68, and the next episode, number 69, will be a little bit different. My fellow podcasters within this industry, Chris Denney of Worthington Assembly and Melissa Hough of CircuitHub, host a podcast called the Pick Place Podcast, where I was their guest. The subject was cleaning circuit assemblies to improve reliability. They asked terrific questions, and we had a very entertaining conversation, which spanned two episodes. So this is the first of two episodes featuring our conversation. Part 2 will air as episode 69 in 2 weeks. First, a little bit about their respective companies. CircuitHub is on a mission to fix rapid electronics prototyping. They are the first automated electronics factory built around a modern tech stack. They help hardware companies produce self-driving cars, satellites, 3D printers, robotics, and to more rapidly prototype electronics to get them to market faster. Worthington is a high-tech electronics manufacturer with nearly 50 years of experience. Their state-of-the-art facility in South Deerfield, Massachusetts, is capable of handling high-tech, complex boards at both small volume and production runs. You can learn more about CircuitHub and Worthington in the show notes. Now, here's my conversation with Chris Denney and Melissa Hough.
Welcome to the Pick Place Podcast, a show where we talk about electronics manufacturing and everything related to getting a circuit board into the world. This is Chris Denney with Worthington.
And this is Melissa Hough with CircuitHub.
Welcome back, Melissa.
Welcome back, Chris.
I am very, very excited for this week's episode. I want to get right into it because we have Mike Konrad, the founder and president of Aqueous Technologies, on the show, and we're going to pick his brain all about cleaning circuit boards, which I know almost nothing about.
And I think I probably know even less than you, so it'll be a very informational episode for both of us.
So the cool thing is Mike is he's a fellow podcaster. He hosts a show called a related show, I should say. He has a couple shows, but a related show called Reliability Matters, which is really geared towards like people like me who actually build stuff and don't design things. But it's still an interesting show, and I think there's a lot of good information that our listeners might be keen to hear. So if they want, they can look that up in their podcast app and follow along. Reliability Matters. But Mike, welcome to the show, and thanks so much for joining us.
Thanks, Chris. Thanks, Melissa. Good to be here. Thanks for the show plug as well. It's nice to talk to a fellow podcaster, and it's unusual to be on this side of the microphone. So usually I'm the one having to think of the question. So I feel very chill and relaxed, and
there you go.
It's great.
Well, I think that makes two of us, because I doubt Melissa's chilled and relaxed. She's just thinking about all the editing she's going to have to do after this.
Right.
These two guys who
we'll try
can
not
go
to
off
make
on
too many
tangents.
mistakes, go off on too many tangents.
Exactly.
Chris.
She's not buying it.
So let me tell you about the time. So Mike, the reason the timing is really good for this, well, for us anyway, is because anybody who has been a customer for Worthington or for CircuitHub, they probably already know that we basically do not offer the service of cleaning circuit boards. We build everything using no clean flux. And if your application fits that production build, then you're going to be a happy customer, because you're going to save a lot of money because you don't have to go through the cleaning process. You don't have to deal with all that. But not everybody fits that mold. And so we're getting more and more customers now that saying, hey, I'd love to use you guys, but I need my boards cleaned. And we're like, here's a handful of other shops you can talk to. Unfortunately, we can't help you with that. But sales team being as they are, they don't want to keep saying no to their customers.
Mm-hmm.
So we got
doesn't exist in the vocabulary of most salespeople, right?
That's right. I was one, and I have the bruises to prove it. That's for sure. And it is hard to say no. It's so easy to say no for us on the production side because we're just like, you want to do that? What? No, we are not going to do that. But at the end of the day, if you say no to everything, then you don't have much of a business anymore. So we want to be able to offer cleaning services to our customer. And if you're listening to this as we publish it, very likely we are not prepared to take orders for cleaned boards yet, but that will be changing in 2021. And we are currently, looking for equipment and processes to help us with that. But I figured before we figure out what machine to buy, we should probably figure out what the heck we're doing, because at least I personally don't know enough about cleaning circuit boards.
And Chris, you are not in the minority there.
Yeah.
You are in the majority. I like to say there's two groups of people. Let's set up a scenario where the big boss comes downstairs from the ivory tower, looks at you engineers and says, we got to do some cleaning. Chris, find us a cleaner. And
sure.
Chris, the young millennial, says,
Mike, get me a cleaner.
Chris goes, dude, says to his boss, dude, it says no clean, man. What are you talking about? We don't need to clean.
See this jar?
No clean.
See this jar? It says no clean.
Right. We haven't cleaned since 8-tracks were popular, right?
Yeah.
And then he turns to the old guy who's a day or two from retirement, the old sage, right? And he says, find me a cleaner. And he goes, I know exactly what to do, boss. I'm going to go out and buy a vapor degreaser, fill it with 1,1,1 trichloroethane.
Oh, trichlor.
And I'll get you in the cleaning business, and then, goes out and, teletypes his wife to say, I'm on my way home. There's either obsolete information or no information. That's
dude, trichlor is the worst. Trichlor that stuff stinks.
Yeah.
It is the worst. Or is trichlor the same as Solvon, or are those two different things?
I don't know. My guess is there were two primary solvents used back in the day. And that day is defined as pre-1989.
That's kind of what I'm thinking.
99.
Yeah.
So between 1989 and 99, these solvents were phased out. And due to a treaty signed by originally 11 countries called the Montreal Protocol. That was an environmental treaty.
Sir. I didn't know that. I had no idea about this.
Oh, let's go there then.
Let's do it.
Yeah. It turned out that scientists discovered through satellite technology that the ozone layer was depleting. And, our current buzzword today is climate change. Before climate change, it was global warming. And then they decided to call it climate change because some people were like, it's cold. How can it be global warming? So they just said, okay, climate change. And then before global warming, climate change, there was ozone depletion. Right. And the ozone was getting eaten up. And there's basically two causes of the ozone layer getting eaten up. One is natural. Cows, without getting into too much detail, cows are a huge contributor to methane gas and depletion of the ozone. And the other is man. Oh, volcanoes are there too. The other is man. And it turned out that the chlorine molecules that are used in these popular solvents would just go right up to the upper atmosphere, and they were like little Pac-Men. They would just gnaw on the ozone layer.
Sure.
So 11 countries signed a treaty in Montreal, hence the Montreal Protocol, in 1989 that provided a 10-year phase out. And it was interesting. Instead of making the product illegal to buy right away, they made it illegal to manufacture after 10 years. So supply and demand, a lot of the companies got out of that business early because they could see it was going to go away. Yeah. So what ended up being, at the time, I used to sell vapor degreasers, which were the technology that used those solvents. And we used Freon TMS, which was similar to trichlor. It was a solvent, boil at a low temperature.
Freon, that's like a brand. That's like
Freon
the DuPont
is a
brand.
product of DuPont. Yes, it's a trademark of DuPont, and it's a refrigerant and a solvent. So you see it in air conditioning systems in your refrigerator, and it was also a solvent.
Oh man, poor Melissa! I'm about to go off on a tangent.
Here we go. Don't edit it out.
So is that R12? Is that like the shorthand for this?
R12 is a refrigerant, a particular type of refrigerant that's used in air conditioning systems.
Right, because I had, not to bore the listeners if they've heard me tell this story before, but I ended up getting the kegerator from the tasting laboratory of a giant Miller brewery that went out of business in upstate New York. And it was built in 1976, and it requires R12 refrigerant in order to operate. Yep. And the old sage in our factory, his name is Brad, and he, in, I forget what year, it was like 1996 or something like that. He was at BJ's and they had a case. It was like December 31st, 1996 or whatever the year was. And they had a case of R12 refrigerant for $1 a can because as of January 1st, they couldn't sell it anymore.
Yeah.
And so I ended up getting that can and putting it in my system. And when I showed it to my friend who, here I'm making it relate again. When I showed it to my friend who he works in HVAC, he looked at that. He goes, how did you get this? This like doesn't exist. I have no idea how I'm holding this in my hand right now, but I'll put it in your system for you.
Yeah. We used to get, because we built and sold vapor degreasers, we used to get the Freon for free from DuPont, right? So they'd send us free. We have 55-gallon barrel. This is before it was phased out. This was probably.
How do they make any money just giving you Freon?
Well, because we were a manufacturer of machines, and we put a little sign saying, when we ran demos, we'd say it's filled with DuPont's, Freon 111 or Freon TMS, and then you go out and buy it, right? So it was just a sample, right? We didn't sell the material, but it was just a good faith sample. So we used to get a 55-gallon drum for free, but they charge us $30 as a deposit on the drum because they wanted the drum back, right?
Sure.
The last price I saw in the late 90s, probably 97, 98, was about $12,000 for that same drum.
Oh, my God.
Plus a $30 drum deposit. $12,000 for the same drum. That was supply and demand. So what happened is during that 10-year phase out, a couple things happened. One was pretty significant. Right now we live, and this is not a political show, obviously, so I'm not going to go down that road, but we live I think it's safe to say, we live in a very polarized society, right?
Yeah.
You are red or
sure.
blue, you are this or that, you are mask or no mask, you're whatever. Everything is polarized. And back then, we would do a treaty, and countries that agreed with the concept of that treaty would sign on. Right now, if we tried to make a treaty that said, let's agree that the sun goes up in the morning and goes down at night, we could not get all 211 nations of the United Nations to agree to that, right? Someone would be a holdout, right?
Because the Finns would be like, not in the northern part of our country, it doesn't. Yeah.
In the winter, right? But in this case, all UN member countries signed on to this environmental treaty. All.
Holy cow.
There's only been 2 treaties in the history of UN treaties that all countries have signed on to.
That's crazy to think about.
And it's an environmental treaty. And it's an environmental treaty, right? Which is
what year is this again?
Well, it was signed in 89. They've been working on it for a few years. Signed in 89 and then fully in effect in 99. So for that,
because one thing I learned about the UN, which makes this all the more impressive that they all signed off on it. Every single country in the world belongs to the UN except for 3. There's only 3 countries that don't belong to the UN. One is Taiwan because there's a dispute as to their sovereignty.
China says they're not a country. And
right,
they say they
exactly.
Are, right?
The other one is in a very similar situation with another country, and it's hurting my brain to think about who it is, and I apologize if we have a listener from there, but that'd be interesting if we did. And the third is the Vatican.
Oh,
yes, that's true. Yes. Technically a country within a country.
Yeah. But anyway, basically every country is in it. So what you're saying is all but the Pope basically signed this treaty.
Yeah, the Pope. Yeah. So what happens when something tremendous like this happens? So back in the day, back when we had actually real print magazines that we used to run real print ads in, before the internet, on the cover of these magazines, it would say 12 months to the Montreal Protocol. And then the next month, 11 months, and then 10, 9, 8. And no one believed it would actually happen. It would be like the EPA coming down and going, okay, guys, starting in 10 years, no more gasoline.
Sure.
No more gasoline, no more fossil fuel. We would just go to sleep at night going, they're going to poke holes.
We would just
the next
laugh.
10 years, it would be perforated and come up with all these exceptions. And it didn't happen. So all the magazines predicted this is the end of first world, manufacturing. Just the dirty countries of the world will continue to build boards, and we'll be at a disadvantage.
Right. Of
course. That didn't happen. So necessity being the mother of invention, what happened? No clean flux comes along. So instead of arguing, how are we going to clean our boards? These guys from Multicore, actually, with their X32.
Sure.
Come up back then. Everything started with an X or turbo, right?
Oh yeah,
turbo. Those X.
Oh yeah.
So they'd come up with this flux and they said don't worry about how you're going to clean it. Just use this. You don't have to clean it at all.
Okay, so let me pause you there because that brings up a number of questions for me. So let's go back now, because one of the things that I don't know that our listeners understand well enough, or if they do understand, perhaps they'd appreciate a reinforcement. My understanding is there's sort of two classifications of flux, and then the tree branches from there. But there's sort of your water soluble residue fluxes, and then your not water soluble, right?
Rosin based fluxes.
Rosin based, which no clean is a branch off of rosin based at the end of the day.
Yeah. That's a good characterization.
And then when it comes to activity levels, there's further branches off of rosin, because there's rosin mildly activated, which is shorthand RMA, and then there's rosin activated, which is just RA, and
there's just R.
Or just R, right?
Right.
So
nobody uses it. Yeah.
Right. So we're talking 1989 still, and it's the heyday of free cans of Freon. What are people like Chris Denney and Melissa using on their boards? What is the popular chemistries to solder boards with?
Sure. Back in those days, if you were doing military type work, you were probably running an RMA, rosin mildly activated. I think that's
so you were using mildly activated at this point.
Absolutely. Yeah. No one used the R or RA. It was all RMA. Is that
just for like soldering copper pipe or something? What was the RA?
No, that would probably be OA or synthetic flux, SA.
Oh yeah.
That's battery acid. But if you were doing military type work, you were running an RMA, which I think by today's IPC definitions is an ROLO.
Whoa. Not everybody knows what you mean by that. You got to explain yourself now.
Oh gosh, no, I'm gonna. So IPC decided, in their infinite wisdom, that we need more designations on flux type. So
of course,
instead of the three basic ones which you've described, or actually four, OA, organic acid, water soluble, RMA, rosin mildly activated, which was 90% of the rosin market, and then RA and R. They would come up with these different designations, whether they were halide free or they had halides, and the level of activity and whether it's a water soluble or a rosin. They came up with a different nomenclature for it. So ROLO, and I forget what R rosin. I got that one. And then one of them is, I believe, whether it has halides and the level of activity. So I don't remember. I don't have the chart in front of me, but they came up with a different designation for it, which
it's like a rating system almost.
It is. It's a rating system. It tells you more things about the flux based on its 4-letter nomenclature than the prior did. It gives you more information. It gives the engineer more information to make an appropriate choice.
I'll try to dig up some info on that and put it in the show notes for anybody who wants to.
It's easy to find. It's easy to find. So if you were doing military type work, you were running a rosin flux. If you were doing commercial type work, you would be running a water soluble flux, organic acid, OA. So if you were running a rosin flux, you were probably cleaning in a solvent. More than likely. You could have been using a dishwasher type early aqueous machine with a saponifier, but you were probably running a solvent with a vapor diffuser. And if you were doing commercial work, say class 1, class 2 type work, again, the IPC standards, class 3 is stuff that can't fail or bad things happen. Class 2 is machines that need to be dependable, but nobody dies if they fail. And class 1 is cheap stuff, right?
Yeah, remote controls, toys,
electronic flea collars, things like that.
Yeah.
So if you were doing class 1, class 2, there's a fair chance you'd be water soluble, and you'd clean it in an inline water only cleaner, or a batch type cleaner, like a dishwasher type cleaner or a kitchen sink or something.
That's where I came from. So when I first got in the industry in the late 90s, we had an inline water, I believe it was water only cleaner, and we did everything with organic acid. And I remember the transition to not cleaning anymore in this new no clean flux. It was a big deal.
It was a get out of jail free card at Monopoly. It was an amazing escape. Now, this is not a scientific number, but I think it's an arguably defendable number. Mm-hmm. About probably 15 to 20% of the electronic assembly industry is high rel, military, space, medical, and the remaining majority is commercial stuff, class 1,
That's
class
right.
2, right? That's probably a defendable number.
Absolutely. I You use the Pareto principle and you can defend it.
Yes, exactly. So the larger group, the majority group of class 1, class 2, stopped cleaning. I mean, we started our business building cleaners in 1992. So we hadn't hit the phase out yet.
Okay.
I can't think of a worse time to get into a business where you're building
Seriously.
a product that 80% of the market will no longer need. Right?
That's right.
So that was interesting. But we started from zero. So it's not like we lost any business, right? We just started from zero. So anything is good. So our market basically, and anyone who built cleaners, their market was to sell to the military type people who were running products that needed to be cleaned or bad things happened.
Yep.
And then everyone else went on, they partied like it was 1999 because it was 1999. And
they were listening to Prince.
And they were listening to Prince. Who wouldn't? I remember the millennial New Year. We partied like it was 1999. That song played all night long. But
yep.
But at any rate, most people stopped cleaning. So there's three groups of people regarding cleaning. Those who used to clean, which was almost everybody, very few exceptions. Then those who are only doing high rel work. And that was from 1999 to probably 2005. That's pretty much the only people who cleaned. And then now there's a third group, which is everybody else coming back to cleaning. People like you, Chris, that are going, my customers are asking for this.
Yep.
And we have to tell them no. There is a very fast-moving tsunami, without making it sound too dramatic, that is approaching and has...
that does sound terrifying.
It sounds terrifying. You should just come buy a cleaner now.
I mean,
Chris.
tsunamis are terrifying. And then if they move fast, I mean...
Yeah. But it's happening fast. And, we've seen, I've been in this industry since 1985, not 1885, 1985.
I've been on this planet since 1984, so we have something in common.
There you go. So you were one when I entered this business. And little knowing you'd be destined to be in this business. So I've seen everyone clean. I've seen virtually no one clean. And now we're seeing, I can't say we're back to pre-89 levels, but we're probably 70% of the way back to pre-89 levels.
No kidding.
Yeah. Oh yeah. The majority, we do polls all the time. I love polling. And we have to be careful when we do polls because we do polls during our webinars, and our webinars are on the subject of cleaning and cleanliness quantification. One of the shocking results we had in one of our polls is we asked our attendees of our various workshops and webinars, what, if you're running no clean, what percentage of the no clean product do you clean? And that number, we've been asking that question for years. And that number started off with about 20, 25%. And then a couple of years later, it was 30 or 40%. Now it's 60 plus percent, which
holy moly.
No, I don't think our customers are any different than someone else. And we're not asking a loaded question. It's a fair question. It's like, if you're running no clean, how much of that no clean are you cleaning? And it is consistently above 60% right now, which tells me more than half of people running no clean are cleaning it. And that begs the question, why are you cleaning? Yeah. And the challenge we have in the cleaning world, and the challenge our customers have, is they think if they need to clean, they're admitting defeat. They must be doing something wrong. Because just like that tag on your mattress that says penalty, don't tear off this tag. They read the label on the flux jar and it says no clean. And what they hear is don't clean.
Right.
So if you have a product that doesn't require cleaning, quote unquote, and then you clean it, you got to go to your boss. You got to go, yeah, I know I sold you on no clean, 20 years ago, but now we have to clean it. But it's not a defeat. One of the things I used to get beat up a little bit when I'd go around the world and give lectures about cleaning. I'd always have a flux manufacturer in the back going, raising their hand going, our stuff's inert. Our stuff is not, we're not the problem.
Right.
And I would disagree with the flux is inert. I would agree with they're not the problem.
Right.
It's not inert.
So if I can pause you on that point, because I want to talk a little bit more about the chemistry before we get into the why we're cleaning it.
Sure.
Because my understanding is, and I'd love to be corrected, and I love to learn that I'm wrong, because it happens to me all the time. I better start to learn to love it, right? You have, again, the organic acid, which has to be clean. That stuff's got to be cleaned.
Within an hour or so, yeah.
Yeah, you're in trouble if you don't clean that.
It's a time clock.
Yeah, and then there's the other chemistries that can sit around a while and then be cleaned later. No clean is more or less a marketing term, correct? For basically rosin-based chemistry that looks good enough that people aren't bothered by the aesthetics of it, but it's otherwise very similar to the other chemistries. Is that true, or is that not true?
It's somewhat true.
Okay.
So it's more than a marketing term. I remember a flux manufacturer saying, no clean doesn't mean don't clean. No clean means if you're not going to clean, this is the type of flux you need to select.
There you go. Okay. That's a good way of putting it.
It doesn't mean clean it. It doesn't mean not clean it. I mean, it's designed not to be cleaned originally.
That's right.
But their take isn't whether you should clean it or not. They're just saying, if you're not going to clean it, you cannot use an OA. If you're not going to clean it, you cannot use an RMA. If you're not going to clean it, you have to use a no clean.
So an RMA could be dangerous to leave on the board. It could cause reliability issues.
Well,
the way that no clean wouldn't.
Yes and no, but more yes. So
more yes.
If you
more so than no clean, I guess is my point.
Yeah, back in the day when televisions were made in Mexico, now they're made in China. But back in the day when all the major manufacturers built in Mexico, if you got an old tube TV, I'm not talking about an LCD TV or OLED TV, I'm talking about a tube TV. If you opened up the back of it, you would see these circuit boards with tubes and all that, sticky, covered in flux. They wouldn't clean them at all. It was like a poor man's conformal coating. And all the dust bunnies and everything that would stick to it, right? It was gross. But back in the day, components were miles apart, relatively speaking. Right. Yeah. I mean, you could not get electrochemical migration, which we can talk about in a little bit. We could not get that phenomenon when these components, when the conductors, the cathodes and anodes were inches apart. And now they're mils apart, but then they're inches apart. So you can just leave a bunch of crap on the board and it's not going to cause a problem. Today, there aren't really any relevant board designs, any conventional board designs that can handle that amount of residue between conductors because the conductors.
You mean a 0.3 millimeter pitch is that's
probably
too
not gonna? Yeah, you probably can't have a dirty thought around a component like that because it'll fail like that.
Oh, how many times have you used that joke? Please tell me, like hundreds of times.
Well, I am sitting next to a soundboard, so
That's perfect.
Yeah. So today, it's all about residue tolerance. It's not about whether the no clean flux is detrimental. It's not about that because the flux is. Well, let me go back a little bit. When no clean flux first came out, I like to call it the contract with no clean. We had a implied contract with no clean.
Okay.
And it wasn't written. It was only inferred. It was implied. And the two promises that we were given were that the residues would be invisible.
Yep.
And the invisible residues would be benign.
Okay. Yes. That is the claim.
That's the claim. It's invisible or near invisible. And even if you see something, don't worry about it. It's fine. Right. And that was a fairly true statement back in the day. But like any contract, fine print. And we didn't read the fine print. And I'm making analogies here, obviously. There was no real contract. But the fine print was, as long as boards look like they looked when no clean flux first came on the scene. So no clean flux came on the scene somewhere between 89, 87, 90, right around there. And what do you think boards look like then? Axial leaded components. Dips, right? ICs. They were all, surface mount was just making its appearance, but surface mount back then was basically a dip with the leads turned 90 degrees. It was
that's exactly right.
High pitch.
Smushed down.
Exactly.
Yeah.
And the pitch between the leads was huge. You can drive a Mack truck under these components, and the standoff heights were huge. So what they said was accurate, totally accurate. And then what's happened over the last 30 years or so? We start miniaturizing, right? We put conductors closer together where you just can't see light between the conductors now. So the amount of tolerable residue, all boards can handle residue, but the question is how much of that residue is tolerable, and that tolerance changes when the pitch gets smaller, when the stand-up height gets smaller, when the voltage is higher, and when the boards are exposed to more moisture in harsh environments, right?
Yes.
All of these, this is a perfect storm. We now have boards that are as miniaturized as they've ever been in our history. We now take those boards and put them through IoT in things that never had boards in them before. We have the electrification of cars, which is putting these not just infotainment, luxury, quirky.
No, it's the safety system now.
It's safety. Exactly. And we can get a whole podcast about that.
Oh boy.
You know, I have two cars, a 68 Mustang and a 2018 GM product.
My dad had a 68 Mustang too. That's a great car. Yeah.
But you know what happens if 100% of the electronics in that car fails, Chris, Melissa? I can't listen to the AM radio.
I was going to say.
It's the only electronics. Everything else is
electrical. It depends. I was going to say it depends on if you include the spark plugs as an electronic component.
I don't count that. I don't count the rotor and the points. I count that as electrical.
Yeah.
But sure. On my other car, if the electronics fail.
Oh my God.
I have adaptive cruise control. It might not brake. It might accelerate. I have lane departure where it actually grabs my wheel and recenters me. What if that fails? What if my rear collision avoidance, front of collision avoidance, blind spot indicators fail, right? It's not just the seat massagers or the heaters or the ventilators. It's or the Sirius XM radio. It's safety stuff.
Yeah.
And where do we take our cars? We take them into harsh environments, and we're building these boards with the finest pitch, as with everything close together, with higher voltages.
Crazy.
And the amount of tolerance for residue today is extremely, extremely low. So why would someone use no clean if they concede they have to clean it? I wouldn't use any other. Well, maybe I would use an OA if I was going to clean everything right away, because OA fluxes are very forgiving. You can solder wood together with OA.
Yeah,
right?
seriously, it's ridiculous.
But outside of that, I recommend that people keep using no clean. No clean is not our competition in the cleaning business. It's our ally. And the reason I recommend staying with no clean is because I could be wrong on this, but I think I'm fairly right. I don't think a new advance in flux technology has come out in rosins or water solubles in 20 years. Maybe they've refined them a little bit, but nothing breathtaking. Every day, these solder companies, flux companies, are refining no clean every day. And they're constantly tweaking it and making them better and better and better. So they're the most.
Well, you said earlier, 80% of the industry is using no clean. That's the market. That's what they're going to keep targeting and keep working on. Yeah.
They're not going to come out with the latest 8-track stereo, when everyone's listening to iPods, right? They're going to continue, the streaming service.
No, nobody listens to iPods. Come on.
That's true.
This is iPhones, Androids.
That's true. That's true. You dated me.
So
this is the non-millennial guest that's on the show.
So the one thing I find interesting is I have, there's no video to this show, but we can see each other. So I have my iPhone in my hand here, and the amount of technology packed into this is truly blows my mind, especially as somebody who makes stuff for a living. I'm flabbergasted every time I pick this thing up. I cannot believe they fit everything into this that they fit into this. So when you talk about super fine pitch and you talk about just insanely small miniaturization, it doesn't get much smaller than that. I mean, sure, pacemakers and so there's some other things that definitely do get smaller, but for the mass market, that is a really, really tiny circuit board. My understanding is that is still a no clean flux product. I believe there are still residues on those boards. Yep. When you're making 50 million of something, that's a whole lot of chemistry and a whole lot of water, and we want to make sure we don't have to do that. So I guess I'm speaking out not not in defense of, because I don't think you're attacking no clean. You're certainly not.
No.
You said earlier
We're
it's your
promoting it.
ally.
Yeah,
right. It has an important place. And one thing I want customers to understand is, if your product is working right now with no clean, you should probably keep using no clean.
Absolutely.
It's going to be in your best interest
Absolutely.
to keep using no clean.
Because cleaning, if you clean a part that has residues, that potentially harmful residues, you make your part more reliable. But if you don't clean your part well, you make your part way less reliable. You are better off, and it's not too many contexts you'll hear me say this, you're better off not cleaning at all than cleaning poorly.
That's right.
So one of the reasons
that
Apple,
is so true.
Oh, it's. I mean, I've seen it. One of the reasons Apple, Samsung, if LG's still selling, one of the reasons they can, you heard of DFM, design for manufacturability.
Yes.
This is designed for non-cleanability. If you are able to make 50 million products a year, all the same, you can design out the need for cleaning. You can actually build dams around bottom terminated components with mask. You can do these little mechanical tricks. You can control the voltage in certain areas. You can control the spacing to a certain degree, because it's a clean slate. You can start with that goal in mind to not clean. And if you have the luxury of this economy of scale, then you can afford to engineer out a process that will save you millions. It's like, the American Airlines took the paint many years ago off their planes.
Yeah. And
they save millions of dollars a year in fuel. And this may be an urban legend. I'd love to believe it's true, but it sounds ridiculous. But it's a common urban legend anyway, that they even took the olives out of the martinis.
Right.
To save
or the
fuel.
Or the salads or something like that. Yeah.
To save fuel, right? So they have this giant economy of scale. And the phone companies, the cell phone manufacturers, all that have the same thing. Now, it's interesting. Several years ago, I was presenting at the Cleaning and Coating Conference, IPC and SMTA Cleaning and Coating Conference. It was in Chicago. And by the way, a little plug, SMTA Cleaning and Coating Conference is happening in Dallas this October. And they Research in Motion, BlackBerry. Remember that, Chris? You're very young to remember BlackBerry.
I had a BlackBerry.
Okay,
I had 3 BlackBerries.
I was a BlackBerry fanatic until I wasn't. But anyway.
Me too. I even had a Storm. You remember that pile of something? Yeah, that was a piece of junk product.
Totally. I miss my keyboard to this day, but that's an old man thing.
Sure.
But they actually gave a paper where they had to clean a board. They had to clean their boards. And like your BlackBerry, they were the Apple of the day, right?
Of course, they were huge.
Yeah, and I'm like, why would they have to clean? They have this economy of scale, all the things we just talked about. Well, they had a problem with solderability. They couldn't get solder to wet on a particular component.
No kidding.
And they determined that the cause was silicon mold release on the component reels that transferred to the component. If you really want to punk your colleague, put a little silicone on a lead and watch them try and solder it. The solder will repel, right? It'll run the opposite direction. This is what happened. So they had to rescue clean a bunch of boards and probably fire their supplier and find a new one.
Yeah, I would say.
But it's not often you see people like that. But mere mortals like us and like all of your customers probably and mine are in a time where the tolerance for residue is at the lowest it's ever been since the introduction of no clean. So do they need to clean? Maybe not. And to your point, and I totally agree with this, is if you don't need to clean, if it ain't broke, don't introduce something new. There's a couple rules of thumb. Don't change things that don't need to be changed, and don't do repair on things that don't need to be repaired.
Amen,
right?
brother.
I mean, if it's cosmetic, let it go, because the moment you touch something, you have an element of failure, a chance for failure. So if you don't need to clean it, don't clean. However, if you are in the ever-growing masses of people who have come to the realization that the amount of residue exceeds the tolerable residue, then you have to look at a cleaning process. And let me just make this one point. I started down this road earlier, and then I got sidetracked. A lot of the flux companies will think I'm harping on the flux, and they're like, our stuff's pretty clean, which is absolutely true. But keep in mind, the decision to not remove the flux was a decision not to remove everything else.
Yeah, right. That's right. That's absolutely right.
And I tell people, I harp on this. I said, do not call it a defluxing process. Because if you refer to this as a defluxing process and someone tells you the flux doesn't need to come off, which may be true, then you don't run a defluxing process. Change the term to cleaning. It's a cleaning process. And it's cleaning flux, and it's cleaning board fabrication residues. It's cleaning hassle fluid residues. It's cleaning component fabrication residues, the mold release agents that can transfer from the reels to the components to the board. It's cleaning human residues. It's cleaning Dorito effect residues after 10, 12, 30.
Not allowed to eat Doritos on the floor.
Exactly.
Especially now that we have to wear masks. That is the most disgusting thing in the world. Do not eat Doritos and then put your mask on.
I know.
I
can imagine the inside of the mask just looks gnarly, right?
That is a terrible life decision.
Yeah, I agree. Doritos are a fulfilling life decision, but probably not a good one either. Health-wise. But so if you don't need to clean, by all means, don't clean. But when the Grim Reaper starts knocking on your door, and it probably will at some point, then I would recommend not changing your flux. Continue using what's worked well for you. And you've got the profile down. And one of the things that a lot of people don't realize is it's not just, well, here's what happens. Let me back up. People will set up a process qualification. They have a new board, a new design, new materials, and they set up this little experiment, maybe DOE or some kind of process qualification. And everything is perfect. The profile is perfect. The peak temperature is perfect. The boards are perfect. The component placement, the pressure on the printer, everything is perfect because it's a process qualification. And then they check the board. It's no clean. They check the board for contamination. They send it out to a analytical lab like Foresight and Kokomo or Process Sciences or wherever. And they do a few $1,000s worth of localized extraction and ion chromatography. And they go, hey, this board's clean. You're good to go. Well, one of those labs, Foresight, just produced a paper where they took that perfect reflow profile that produced residue results that were totally fine, well within the safe zone. No need to clean. And they lowered the peak temperature by 4%. So they lowered it from 250 to 240, 10 degrees, 4%. And resubjected those boards to localized extraction ion chromatography. And they had increases in residues up to 600%. 120% was the lowest, 600% was the highest.
Now you're saying these are boards that did not get cleaned. So they sent their boards with no clean flux on there.
Yep.
Okay.
And when the profile was perfect, like it would be in a process qualification, when the profile was perfect, the boards were arguably clean enough not to require cleaning. When they modified their reflow process by 4% on peak temperature, they had boards that were exceeding what the lab considers reliable in terms of residue.
Wow.
So, it's not
great. Now you know what's going to happen, Mike. Everybody's going to be calling me to get their reflow profiles,
Yeah, right.
Cutting all this out. This is all getting cut out.
Yeah. delete. Yeah, that's the point. It's the people, users who want to continue not cleaning. It's a perfectly sound strategy. It's just their process window is tightening. It is tightening. And we can do one of two things. We can continue to tighten the process window and make it so we don't have to clean. And that is a pure economic, scale decision. Is it worth putting a little extra time and money and effort into not having to clean? Because not having to clean maybe saves us a certain amount of money. And the cost of tweaking up the process control is less than the cost of cleaning, then that's just an economic decision. And that's a fair one. If they realize if you're running 3 shifts and they realize that third shift, spooky things happen more than first shift, which is a phenomenon. And maybe throughput is a little bit more important than being within, 4% on a reflow profile where otherwise everything would be fine. Then cleaning might just expand the process envelope. because
Sure. Yeah.
if something did go wrong, don't worry about it. We're taking it off anyway, right?
Right.
So, yeah, eat Doritos over the board, no problem. We're going to clean it anyway. Don't suggest.
Yeah, you hear that, Neil? We're going to eat Doritos.
We're
going to eat Doritos on the manufacturing floor now.
Exactly.
So I think that's a good summarization of the why. And I think basically at the end of the day, every customer has to decide for themselves whether or not, cleaning ends up being a requirement for their application or whether or not they can get by with what we've been providing for them so far. Hey, everybody. I hope you're enjoying our conversation with Mike. I thought it was great. I really loved learning about the history of circuit board cleaning and why we've decided to clean circuit boards in the past and why we might decide to clean circuit boards more in the future. I was fascinated by it, and Mike had so much to share. Well, he had so much to share that we decided to break this episode up into 2 parts. So the next episode that will come out will be mostly all about the how of cleaning circuit boards, how exactly we do that, and what equipment it takes and what chemicals it takes and how to, keep those chemicals out of our rivers and streams. And it was a great conversation. So I think you'll enjoy that too. Until then, thanks so much for listening.
Thanks for listening to the Pick Place podcast. If you like what you heard, consider subscribing in your favorite podcast app, and please leave us a review on Apple Podcasts or wherever you get your podcasts from.
Well, that's another episode. Thanks for listening to part 1 of this 2-part episode. Thanks also to Chris Denney and Melissa Hough of Worthington and CircuitHub, respectively. Check out the Pick Place podcast on Apple Podcasts, Google Podcasts, and many other podcast sites. And while you're at it, be sure and subscribe to the Reliability Matters podcast, also available on Apple Podcasts, Google Podcasts, Spotify, and virtually wherever you get your podcasts. We release new episodes on the 2nd and 4th Tuesday of each month. Also, be sure and check out our newest podcast, the Concept to Creation podcast, where we have conversations with EMS industry entrepreneurs about their journey into business. They discuss their successes, failures, challenges, and inspirations, and provide advice for budding entrepreneurs. These are fascinating conversations with the leaders of our industry. We release new episodes of Concept to Creation on the 1st and 3rd Tuesday of each month. Thanks also to Circuit Assembly's PCB Chat at PCBchat.com and Ascendo Reliability's Reliability.fm for syndicating the show. Until next time, stay safe, stay healthy, and stay happy, and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the 2nd and 4th Tuesday of each month for new episodes of Reliability Matters.